SOLIDWORKS allows you to design just about any product you can imagine. However, it may not always be clear whether the product will meet the demands it will face in real life. To gain some insight, the traditional approach has been to manufacture a prototype of the product and test it to see if it works. While this approach has proven to be effective for many years, it's also proven to be expensive and time-consuming. Computer-based design validation, like SOLIDWORKS simulation, has changed this approach. Now, instead of manufacturing and testing real parts, we can validate designs virtually before committing resources to a prototype. This approach improves product design early in the development process and reduces the number of prototypes necessary, resulting in a shorter, less costly design cycle. In SOLIDWORKS simulation, our validation process consists of 6 basic steps: defining geometry, assigning material properties, creating a study, defining the operating environment, processing, and reviewing results. Throughout the course, you'll see these basic steps repeated each and every time we validate a design. Let's take a quick look at each step. Defining geometry simply means we need to have a part modeled in SOLIDWORKS before we can do anything. If your part or assembly is already modeled in SOLIDWORKS, then step number 1 is complete. The second step, assigning material properties, provides further definition about the product being analyzed. It's not enough for us to know what the part looks like. We also need to know what it's made of. The third step is creating a study. SOLIDWORKS simulation is capable of performing different types of validations or studies, from structural to fluid flow. And because of this, it's necessary to tell simulation what type of study will be performed. This sets the appropriate stage for the remaining steps. Next, we have to define the operating environment the product will be exposed to. This includes how the product will be held. For instance, will it be bolted to something, or simply sitting on a table, as well as what outside forces will be acting on it. Consider a simple product, a hook used to hang artwork. It will likely be fastened to a wall by a screw, and the force acting on it will be the weight of the artwork. Now, this is an example of the operating environment for the hook. Step 5 is processing the model. Based on the information provided so far, the model geometry, material properties, type of study, and operating environment, how will the model respond? To predict this, simulation does 2 things. It breaks the model up into something called a mesh, and it solves numerous equations, resulting in a mathematical prediction of how the model will behave. The final step is to review results. This is the critical step that will tell you if your design is ready for production, or if you should go back and make changes. Either way, the outcome is a better, higher quality design that you can take to the next phase of development with confidence.